Welcome to this explainer. I am absolutely thrilled you're here today. We are going to peel back the layers of how large language models actually work. We hear about AI every single day, right? But there is a massive gap between the magic we see on the surface and the actual mechanics operating under the hood. So we're going to break this down into 3 distinct layers today. We'll start with the big picture for beginners, then we'll move into practical frameworks for intermediate learners, and finally we'll dive right into advanced architectural strategies for enterprise professionals. Let's get into it.
But before we really start, let me hook you with a question. Why does a genius machine, an AI that is literally capable of writing award-winning poetry or summarizing massive, complex legal documents in seconds, why does it so often struggle to calculate a simple restaurant bill? You've probably seen it happen. You ask it to add up a few items, and it confidently spits out a completely fabricated total. This phenomenon, well, it's known as hallucination. And to understand exactly why this happens, we have to look at what the machine is actually doing.
And that brings us right to layer 1, the illusion of understanding. Okay, let's dive into this. To really grasp this beginner layer, the absolutely crucial mindset shift you need to make right now is shattering the myth that AI actually thinks or knows facts in the human sense. It doesn't have a brain storing verified truths. Instead, it relies on a mathematical framework built on something called a token. You can kind of think of tokens like Lego bricks. When we humans see a long word, say unbelievable, we just see a single word. But an AI might snap it into separate little Lego bricks. It sees 3 different tokens, like un, believe, and able. Every single prompt you write and every answer the AI gives back is just a sequence of these tokens snapping together.
Because it relies on these tokens, AI is fundamentally a probabilistic engine. Think of it as a highly advanced version of your smartphone's autocomplete. When you ask it to solve a math problem, it isn't pulling out a calculator. Not at all. It is simply predicting the most mathematically probable next token based on the billions of pages of training data it's seen. It's essentially just guessing the next word. And that is exactly why it confidently invents answers when doing math. It's optimizing for language patterns, not arithmetic accuracy. It just wants to sound right.
So with that baseline, let's transition to layer 2, the framework. For the intermediate learners and working professionals out there, you might be wondering, how do we actually control this probabilistic engine so it does what we want it to do? Well, through prompt engineering. And this brilliantly illustrates the massive difference between hoping for a good result and actually engineering one. Take zero-shot prompting. This is when you give the AI a task with absolutely 0 examples, relying entirely on its baseline probability to guess what you want. In contrast, we have what's called few-shot prompting. Imagine you're building an automated resume screener. Instead of just vaguely saying, score this resume, you provide a few specific examples. You show the AI exactly how to weight, say, a computer science degree versus 4 years of real-world experience. By feeding it a specific pattern, you radically tighten the probability of getting exactly what you need.
But we can take this a step further with a really powerful framework called chain of thought prompting. Instead of just asking for a final decision on our resume screener, we actually force the machine to think step by step. We command it to first extract the facts, then apply the scoring criteria, sum the total, deliberately check for missing requirements, like say an employment gap, and only then output a final decision. By forcing the model to generate those intermediate steps, you drastically reduce errors and ensure a highly reliable outcome. Now, why go through all this effort? Well, because of a pretty stark reality. 60%. A basic AI setup, if you just throw it at a problem out of the box, might only hit around 60% accuracy. The other 40% of the time, it might fail completely or hallucinate. And let's be real, in a real-world business process, a 40% failure rate is completely unacceptable. You just cannot put that into production.
Which brings us perfectly into layer 3, the architecture of reliability.
For the advanced, strategic thinkers tuning in, we need to elevate the conversation here. Because even with perfect, highly sophisticated prompting, how do we architect systems that don't cost an absolute fortune or hallucinate when faced with really unpredictable user inputs? When you're designing AI for the real world, you are constantly balancing the 3 pillars of enterprise AI: security, reliability, and cost efficiency. So the crucial point is you simply cannot rely on sending every single user query to a massive, generic, and highly expensive AI model. Doing that will just burn through your computing budget and open you up to massive unpredictability.
To balance those pillars, there's a massive mind shift happening in the industry right now. On one side, you have these massive generic models. You know the ones. They're trained on the entire internet, they're highly unpredictable, and they cost a fortune to run.
On the flip side, you have hybrid specialized architectures. Strategically, it is vastly superior to use smaller, specialized models combined with hard-coded, deterministic rules. I mean, think about it. Why use a 120 billion parameter model to answer a basic question when a specialized 8 billion parameter model can do the exact same thing, cheaper, faster, and way more reliably?
Let's move to and see how this builds into an actual workflow. In a smart enterprise architecture, we use something called intent-based routing. This is the core difference between standard generation and memory retrieval. When a user asks a really simple, common question like, "Hey, how do I reset my password?" we absolutely don't ask the AI to generate a brand new answer on the fly. That just risks a hallucination. Instead, we use the AI merely to understand the user's intent, and then we retrieve a pre-written, 100% accurate, pre-approved answer right from our memory database. We save the expensive, generative AI only for the truly complex, unique tasks.
And that brings us to our final takeaway. The true power of AI doesn't lie in the size of the machine, but in the clarity of the human intent guiding it. This really unites everything we've talked about today, from understanding that tokens are just predicting probabilities, to using few-shot and chain-of-thought frameworks to guide the machine's focus, all the way up to designing enterprise architectures that prioritize specialized memory over generic guessing. Human design, your design, is what actually makes AI valuable.
I want to leave you with this provocative thought. This technology, at the end of the day, is just a probabilistic engine waiting for instructions. It requires guardrails, it requires structure, and most importantly, it requires vision. So what human intent will you use to guide the machines of tomorrow? Thank you so much for watching this explainer. Keep learning, keep experimenting, and I'll see you next time.